Hey guys, this is 21B. It might seem a bit strange that we're doing exercise from chapter 21 when we've been focusing on chapter 18, but it is related, so we decided we'd put that in here as well. Um, what we see here should be reasonably familiar to you. So we've got our f of x, our normal function, then we've got our derivative here. So we've practiced a heap of differentiation to get our derivative, but we've also practiced anti-differentiation to get our normal function again. There's another part of this that you haven't seen just yet, and it is a capital F of x. Now, capital F of x would go over here. Okay, now it follows the same sort of thing. We can get from capital F of x to f of x and back using those same things. So if you want to get from f of x, from capital F of x to f of x, you would be differentiating. And if you want to go the other way around, you'd be anti-differentiating. Now we already know what these two are. This has just been introduced to us. So it explains what our capital F of x does just here. So it can help us find the area between a curve and the x-axis between two boundaries. So I've got a little bit of a demo here. This is our curve. I don't know exactly what the rule is, but our boundaries are where A and B is. Okay, so if I extend those boundaries up, I'll just do a little dotted line to show where they are. F of x is helping us find that area between the curve, which is this, and the x-axis between these two boundaries. So if I was going to color the area in, it's helping us find this bit here. Alright, so we're going to be finding areas in this next section. And the way we do that is using this rule here. Okay, now this section of the rule should look reasonably familiar to you. It's when we're anti-differentiating, or integrating is another way we can call it. A and B here are new though. Remember, A and B are our boundaries over here. Now what it's saying with this section is we need to anti-differentiate our f of x, because we want to end up getting to capital F of x. So if we move on in the rule, what this part is showing us is our antiderivative of f of x. So we've got our capital F of x, that's what we need, but it's still telling us where our boundaries are. To find out the area between the curve and the x-axis between the boundaries A and B, we then need to sub b into our capital F of x, and then take away capital F of x where A is subbed in. Now that might seem a little bit complicated at the moment, but we'll do it in steps, and hopefully we can see what's or how it works. Before we do it this way though, I've got an example here that's kind of going to help us prove that this rule actually works. Alright, now here's a simple rule for us to start. We've got f of x here, and the rule's 2x. We want to find capital F of x. So remember, we're just anti-differentiating this. This is something that we have done, a handful of times before. So if we anti-differentiate f of x, we get capital F of x. Now remember, for each term, and there's only one here, the power goes up 1. So it's going to go from 1 to 2. And then we divide by our new power. And we don't forget to add c as well. So our capital F of x is x squared plus c. So that's the kind of thing that we're going to be doing as part of the rule. But we're not going to use the rule to find the area just yet. We're going to do something else. So it says draw the graph of f of x equals 2x. I'm sure we can do that. And show the coordinates on the line where x is 0 and x is 3. So 2x is just a straight line, isn't it? With a gradient of 2. So it might look something like that. It keeps going both ways. Now it wants us to give the coordinates where x is 0. So if we sub x is 0 into there, it's going to give us 0. So x is 0, y is 0. And where x is 3, let's say that 3 is here. So where x is 3, if we sub 3 into that rule, 2 times 3 is 6. Cool. Now, Using what you know about the area of triangles, find the area under f of x between x is 0 and x is 3. Okay, so f of x is our line here. We want to find the area between that line and the x-axis between x is 0 and x is 3. So I'm going to colour that area in. We want to find this space, this area inside here. Now that's just a triangle, isn't it? So we've got a triangle. I might draw it again here. We've got a right angle triangle with a base that's 3, a height from 0 to 6, so its height is 6. The area of a triangle is half base times height, isn't it? That's something that we can hopefully remember. So half times 3, which is the base, times 6, which is the height. Right, 3 times 6 is 18, and half of that is 9. So that area there should be 9 units squared. Cool. What we're going to do now, when we move over to D, we know the area of this because we know how to find the area of triangles, but we're going to prove it using this rule here. Okay, so let me move over to D. Use the formula to find the area between f of x and the x-axis between x is 0 and x is 3. Cool, so just what I said before. I'm going to write the rule down here again, just so I can keep referring to it. Okay, so this is the rule that we're using. Now, let's worry about our boundaries to start with, our A and B. So A is your smaller one, so our smaller one is 0. Our higher one is 3. We want to put our rule in here. So our rule was 2x. Now the next part, it's just kind of a spot where we show what capital F of x is. So we actually found what capital F of x was earlier as part of question A. So we found capital F of x was x squared plus c. Now normally you'd have to add, normally you have to add that c, except whenever you're finding the area you don't. The reason you don't is because it ends up cancelling itself out here. So you can add it in here if you want to, but I'm not going to bother because I know it's going to cancel out. Don't know why I wrote A and B, because I know their values, which is 0 and 3. Okay, so now for the next bit. We're subbing B into our capital F of x. Okay, so B is 3, our capital F of x is x squared. There we go, so that's capital F of B. And we need to take away f of a, so that would be 0 squared. And our answer is 9. See how it's the same as before? So using this method here, we found out that the area under the curve, or between the curve and the x-axis between x is 0 and x is 3, is 9 units squared. Now that example, it's really easy for us to find the area kind of manually or using the area of a triangle rule. It's a little bit harder when we have rules like this, because this is a curve, whereas the one earlier, it was just a straight line. So with this question here, or this part, we're going to sketch it just so we can show, have a bit of a visual representation of what we're trying to find out. So if we're going to sketch this here, hopefully we can see that it is a parabola, because it's x squared. It has a negative out in front of it, so it's not a smiley face, it's going to be a sad face, like with the tail pointing down, but it's also been moved up 4 units. Our y-intercept is going to be 4. So I'm going to draw that right now just so we can see what it looks like. So it should look something like that. Now whenever we're drawing a graph, you know, we should show all those intercepts. So we should probably find this one and this one. So to find an x-intercept, you just make y equals 0. There we go, so our x-intercepts are at 2 and minus 2. Sweet, so I think we've finished this question now, we've shown it. It's asking us to find the area under f of x between -2 and 2. I'm really quickly going to shade that space so we know what we're finding out. We're trying to find this blue area here. Right, so we can't use the area of triangles here, can we? We're going to have to use the rule that we looked at before. So there's our rule as a bit of a refresher. Right, so our boundaries, let's think about those ones first. The lower one is -2, the upper one is 2. Our rule is minus x squared plus 4. Alright, now what we need to show is we need to anti-differentiate that or integrate that. Okay, so let's do it in this box here. So the squared's going to go to 3. It's going to be divided by that new power, and x appears under that 4. We don't need the c. Alright, now the lower boundary is -2, our upper boundary is 2. Alright, we're going to have to do some substitution now. So we want to find capital F of b. So we're substituting b in, which is this one here. So this is going into the x's. Okay, there's my f of b. And I want to take away capital F of a. Okay, I've done all my substitution into there. We can go through the whole, actually no I haven't, I should have put 2 there. We can go through the whole process here. There's going to be fractions involved. The answer that you're going to end up getting, because I don't want to take a heap of time up for the video, is going to be 32 on 3 units squared. Alright, cool. So that one is now done. So it might have seemed a little bit harder because we had a more difficult rule, but we're doing the exact same thing. The next part, we're going to use a CAS. So I might move over and show you using the actual CAS. But we want to find the area under f of x between x is -2 and 2. So we're doing the exact same thing. We're just using our CAS to do it. You're going to see that it's going to take less time, and we should hopefully be confirming our answer just here. Right, we've started a new document on our CAS. What we need to do is first go to Menu, Calculus, then Integral. Hopefully that's familiar because that's the way we would anti-differentiate using our CAS. So hopefully, as I said before, this is familiar. Now these 2 bits here, you see these kind of greyed out dotted boxes here? We were ignoring those beforehand. We were just putting our rules that we wanted to differentiate into here. And then pressing enter, and it would anti-differentiate for us, sorry. Not differentiate, anti-differentiate. This time we're finding the area, so we need to actually use these 2 here. Okay, now we wanted to find the area between x is -2 and x is 2. We need to put our rule in, which was -x squared plus 4. And inside this little box here, you always just put whatever variable is used in here. So normally it's going to be x. We can see that x is used in here. So dx at the end. Press enter, and that is the same answer as we found before. So you can see that's a super quick way to do it. It is important that you practice a few times by hand as well.